Welcome to GP Corrugated, where we manufacture and sell corrugated sheets, standard corrugated containers, and a variety of specialty packaging products. Today, we'd like to show you how we make our products.
The beginning of all corrugated packaging is corrugated board. A series of sophisticated machines acting in unison to create the corrugated board is called a corrugator. The raw material of corrugated board are the container board grades of paper. Liner, which becomes the flat facings of the board, is primarily made from the long fibers of softwood trees. Medium, which becomes the fluted middle layer of corrugated board, is made primarily from shorter fibers from hardwood trees. The first step in making corrugated board occurs in a machine called a single facer. A single facer combines a liner and a medium to form a single face web. To do this, the medium passes through a set of corrugating rolls under high heat and pressure to form the flutes that give corrugated board its strength and cushioning capability. Each set of corrugating rolls are made in specific flute profiles to create the performance attributes needed for the finished packaging item. A pressure roll loads the correct pressure and also brings the liner into contact with fluted medium after a cornstarch-based adhesive is applied to the flute tips by the glue roll. The glue roll turns against a metering roll to control the proper amount of adhesive that is delivered to the flute tips. It is critical that the correct pressure is applied to the corrugating rolls and that the adhesive reaches the proper temperature and consistency to form a strong bond between the liner and fluted medium. This combination is called the single face web. The single face web then leaves the single facer and is elevated to a bridge that carries the web to the double glue unit and the double backer. The liner and corrugated medium are fed into the single facer from opposite sides via a pair of roll stands for each. They are connected by a device known as a splicer. The splicer allows for changing from one roll to another without stopping the machine when the roll is consumed or when a change in paper grade or width is required. As roll stock is unwound and heads to the single facer, the paper passes around heated rolls or preheaters that bring the paper to the proper temperature for the corrugating process. Wrap arms control the amount of time that the paper is exposed to the heat, enabling a degree of control in increasing or reducing heat to the paper. The single face web is carried up and away from the single facer by incline belts. The web folds up in festoons for the length of the bridge until it enters the E&L section of the bridge that leads to the triple stack. This allows the single face web to cure with a firm bond, so the integrity of the flute structure is not disturbed. If double wallboard is being made, both of the corrugator's single facers are running and delivering two single face webs to the bridge to be combined at the double glue unit. The single face web is threaded through heated rolls and into a machine called the double glue unit that applies the cornstarch-based adhesive to the flute tips. The liner that will become the outside facing of the corrugated board is threaded through the heated rolls on the bottom of the triple stack. The outside or double-faced liner is joined to the single face web as the board is pulled into the double backer. The double backer generally has a top and bottom belt that pulls the board through the machine. The double backer has a series of heated plates that continue to transfer heat into the board to cure the adhesive bond. It is the belts in the double backer that pull the board through the wet end of the corrugator and push it to the dry end, where the combined board is scored, slit, and cut to finished specifications. After the board goes through the double backer, it passes through a shear that severs the board to permit order changes and then into a slitter scorer. The slitter scorer slits the board into the proper width and, if needed, places the scores into the board to the specific dimensions. The state-of-the-art slitter scorer shown here has two separate slitter scorer sections. One section is setting up for the next order, while the other is running. When it is time to change orders, the shear severs the board to create a small gap to allow the slitter scorer sections to either drop in or rise from the board path, so the board can align between the top and bottom shafts that the scoring and slitting heads are mounted on. This feature allows order changes to occur at line speed. After the board is slit and scored, it continues to the cutoff knife. The cutoff knife cuts to the precise dimensions requested of the finished corrugated sheet. Most corrugators have an upper and lower knife, so that two different orders can be combined to run on the same width and grade of paper. There are exit rolls that eject the cut sheets onto belts that shingle the sheets to the stacker bays. The stacker beds of the corrugator accumulate the sheets into stacks, which are then discharged on moving belts for the stacker operators to perform quality checks and prepare for strapping and shipment. Converting machines turn corrugated sheets into boxes. These machines print designs and branding onto the boxes and cut the boxes into the proper dimensions for their need. There are two main types of machines: rotary die cutters and flexo folder gluers. The flexo machine glues and folds the box upon completion, while the rotary die cutter leaves the box unglued and flat. Rotary die cut boxes are typically formed by hand, such as pizza boxes, or wrapped around a product and joined on a customer's equipment. A rotary die cutter also has the ability to produce multiple boxes from each sheet, whereas a flexo machine yields one box for every sheet. Through a series of lasers and optical sensors called photo eyes and communication between an inventory management system and real-time production scheduling, material is transferred to each machine center onto an in-feed conveyor. Automatic transfer carts keep each machine fed with corrugated sheet stock. Each stack is broken down into smaller sections called blocks and shingled individually to a feed table. The sheets are fed via a set of feed wheels that work in conjunction with feed rolls that insert the sheet in the machine. Feed rolls are made of a soft durometer material that prevents the board from being crushed. Maintaining board caliper or thickness is essential to providing overall board strength to the final box. A vacuum transfer system carries the sheet through the machine across multiple print sections. On a rotary die cutter machine, the designs and branding are printed on the bottom of the corrugated sheet stock. After the stock moves through the print section, it reaches the rotary die cutters. There are different cutters for every box type that the factory produces. The cutters are built from two half cylinders with metal blades embedded, as well as foam rubber sections to eject the cut board scrap pieces. Scrap is recaptured and recycled back to a paper mill to be used in future roll stock production. The next section is called the scrubber, which removes any remaining loose cutouts and any rough edges on the cut sheets. The sheets are then shingled again to slow down the speed in which they reach the stacker. If the cut sheets hit the stacker too hard, it will damage their edges. The stacker beds accumulate the sheets into stacks, which are then discharged on moving belts for the stacker operators to perform quality checks and prepare for strapping and shipment. The beginning of the flexo process is very similar to that of the rotary die cutter. Stock is fed into the conveyor by the automatic transfer carts. Each stack is broken down into blocks. In this flexo machine, the printing is done on the top of the sheet, so the stock must be inverted. The stock is transferred to a pre-feeder, where the stacks are inverted. This automation eliminates the need for manual inversion. The sheets are then shingled and loaded into a feed bed, where feed rolls insert the sheet in the machine. Print plates are mounted on a cylinder, and an ink system allows ink to be applied to the print plate, where it transfers the ink to the board as it passes through the machine. This machine uses rotary die cuts as well, but it only produces one box per sheet, unlike the rotary-only cutter, which can produce multiple boxes per sheet. The scrap is again recaptured and recycled for future roll stock. On a flexo machine, glue is applied in preparation for folding. After the glue is applied, boxes are carried through a folding section with vacuum-assisted belts and a series of folding rods, forcing the panels to fold in the proper sequence. The folded box is now glued and joined as it exits the machine and is stacked into bundles to the customer's specifications. Added compression time is given to allow the glue to fully cure. Depending on customer specifications, each bundle is strapped together to provide for stability in transit and ease in handling at the end user. To aid in the quality process, especially at high speed, a high-speed detection system called Clear Vision is used to monitor glue placement and gap measurements on every box. A high-speed camera is placed at the point of glue application and can detect the amount and thickness of the glue lines, as well as the measurement of the slots in the front and back of each box. These measurements are compared to a developed standard that can predict whether a bad box will be produced as it travels through the machine. Any out-of-spec box that is detected will be sprayed with the UV coating, and the bottom of the bundle will also be sprayed. As the bundle travels down the conveyor system, a black light detects the UV coating and will eject the bundle so that an operator can locate the off-quality box and remove it prior to reaching the customer. To account for the speed of production, a doubler is used to assist crew members in combining each bundle in preparation for load forming. The doubler stacks bundles on top of each other. These combined bundles are then assembled into a specific stacking pattern to meet customer needs. Load tags are inserted into each unit to uniquely identify each load as it is sent to shipping to be made ready for delivery to the customer.
At the end of another workday, you can rest easy knowing that you have the very best corrugated supplier in the industry. Whether you need corrugated sheets, standard corrugated containers, or specialty packaging products, we hope you'll look to Georgia Pacific as your supplier of choice. Safety, sustainability, innovation, quality, customer focus, and value creation. It's in our DNA in everything we do.